Mä en kohtele mun hiuksia kovin hyvin, joten mä haluan vahvistaa niitä. Siksi mulla on aina keltaista Elvital-hiusnaamiota kotona. Sen hoitava koostumus on mun hiusten pelastaja. Joskus mä levitän sitä kaikkialle hiuksiin ja joskus vain latvoihin. Vaikka mä föönaan, letitän tai kiharan niitä. 2 minuuttia, siinä kaikki, koska olen sen arvoinen.
All right, everybody. I was having so much fun in the lobby that I didn't notice we were supposed to start already. So, welcome to everyone. My name is Aleksi Suhonen. I'm from TREX, and at first I want to thank everyone for showing up, and especially I want to thank our sponsors. Arista is our vendor sponsor, and then we have a bunch of other sponsors, including Farsight, Physics, which is the other exchange point operator in Finland, or the other big one. There are, of course, now more than just Physics and TREX in Finland. RiveNCC is also one of our sponsors. They like to see communities like ours grow. And then we've got a lot of volunteers here. Let's start from the front row. There's Raymond Jetten from ELISA. He's making sure our network. Let me see about the background. I don't know who set this up. It was just there. We'll talk about this later. So Raymond makes sure that we have access all areas in this building and that we have very... And then we've got Nicola Tuveri, who will be taking care of the presentation machines. And then the big hairy guy at the back looking at his camera will be looking at his cameras all day and just incidentally looking at anyone else. And the older man, Pekka Tupamäki, next to him, he's in charge of all our printouts and a lot of our presentations, like the one that has been going around during the breaks. And who else? Erik Hakkarainen was out there greeting you and giving you your badge. And also he was our chauffeur when we went and bought stuff for the sauna this evening. Who else? Maybe I should always write down a list of people who are volunteers so that I don't forget anyone. Well, I'll thank the rest of our volunteers later. Well, without further ado, I guess I'll introduce Andy Davison, who a lot of you have probably already met elsewhere, but he's a very wonderful person, a grand old man of the internet in the UK and all over Europe. He's also on the board of the EURIX.
So, without further ado, I think Paul is already in the room, isn't he? So Paul is going to present a paper on the secure internet exchange. Is he in the room already? Paul, I see you over there. Hi. Please feel free to come onto the stage when you're ready. It's a real pleasure to have you. Thank you for coming over. Were you in Europe already, or have you made the trip? Very good. Glad to see you, Paul. Thank you.
Hello. How about if I say no thanks? Okay, good. All right. So some of you know that I've been doing internet exchange stuff for a long time. I was the first person to do the Palo Alto Internet Exchange, and there's a great story there which I'll tell you in the sauna about how my boss wanted to fire me, but he couldn't because he already had. But I've always liked the idea that the industry, the community, will build something for itself rather than waiting for the government to do it or waiting for the phone companies to decide how to do it. I think the internet and its ability to overtake the OSI market growth back in the 1980s and 90s really demonstrates what can happen if we focus on the result rather than on the process. So that means that even though I never met Steve Jobs, and he's dead now, so that's not going to happen, and I'm fairly sure we wouldn't have liked each other, but he's said a lot of things that that resonate for me, that there are motivational posters all over Silicon Valley, and one says that it is easier to get forgiveness than permission. And in that sense, let me tell you about the Security Information Exchange. Maybe page down. Oh, the focus wasn't there. Page down. Oh, this is going to be ugly, isn't it? F5, he says. Nope, that's not it. All right, so I guess I sent the wrong kind of file or something, but Acrobat Reader, I thought that's what we had. You know, I thought it was just me, but I noticed everybody struggles with Windows like this. F5?
No? More suggestions?
Full screen mode? There we go.
Control. Okay.
All right. Yay! It takes a village to run the app. Okay. Right, so we like competition. I think all of us do. I mean, we don't love it when we lose, but we like the resulting economy of both scale and efficiency. And yet, there are good and bad forms of competition. And I just want to say, I am never going to argue that somebody shouldn't make the best widget they can and try to get market share for it and try and change the world or make money for their shareholders. That is okay, as long as you keep the larger picture also in mind. In particular, you must respect the rule of law. I've made a lot of controversial statements about internet companies who skirt the rule of law as much as possible and are behaving to the extent that we allow them to. They're behaving in a post-national fashion as though this was the movie called Rollerball rather than actual human history. I really want to focus on the recognition of rights, even rights that somebody might not have by law. Sometimes there are moral rights that have to be observed. And if the only way that you can win a competition is by skirting those rights, then you should lose. And I'll be trying to make sure that you do. And so that's why I started the first anti-spam company back in the 90s and invented the RBL and got sued by everybody who wanted to send spam and couldn't because of me. Not everything that is not illegal is okay to do. Not everything that can be done should be done, might be the better takeaway there. And I want to say that if you do keep this larger context in mind in your competitive work, both design and implementation work, you may find that there's a sweet spot where doing what is best for everybody also turns out to be best for you. Certainly, every company who has tweaked the TCP congestion control algorithms in their product in order to take an unfair share of the path bandwidth has ultimately discovered that two can play at that game and that they also will lose. And ultimately we've come to a conclusion over the years that everybody really should observe the congestion control algorithms, even though there is a way to get temporary singular advantage by ignoring them. So that's, again, an example of finding the balance. There's a sweet spot between what is best for an innovator and what is best for the economy and the ecosystem that we play in. Don't have to, in Finland, I don't have to say much about non-cooperation. You guys had the first anonymous remailer. Remember that back in the 80s, so no stranger to controversy are you. But the thing that has changed and that not everybody fully appreciates is that in the pre-internet era, non-cooperation had a kinetic component. It would be a truck bomb, or it would be an airliner full of terrorists, or it would be something, a missile, something that could be stopped at the border using kinetic defenses. That time has passed. I'm not sure that it will come back. It is so much easier to gain advantage over your opponent by infiltrating their digital economy that it's just, there's no comparison. It's not even the same order of magnitude. It's much better to take somebody over from the inside. That has really underlined my work in the last, let's say, 12 years. Some of you know I was at Internet Systems Consortium, which is where Bind came from, or well, it came from Berkeley, but we took it over in the 90s. I started that company and worked there for 18 years, but in 2007 I saw these trends, the non-cooperation over digital media, as sort of the new way that international tension was going to be maintained, and that winners and losers and equilibriums would be determined. And so I left a lot of the DNS work of ISC to others, and I focused again on internet security. And the result was the Security Information Exchange. I'll explain how that came about. So let me talk about sharing of threat data. Again, in this audience, you probably feel all of this, but you may not realize how many people feel otherwise. We've got, I live, for my sins, within driving distance of Sand Hill Road, which is the source of most venture capital in Silicon Valley and in the United States. And somebody on Sand Hill Road starts an internet security company every day and twice on Sundays, and they all start with the same requirement that they have to race toward first revenue and then race toward profitability and then race toward an exit. There is no burden of pleasing the customer. If the customer is pissed off but you got a good exit, then you are considered a winner. There's no sense of trying to improve the ecosystem or change the business conditions of the bad guys or anything else. It's all about just the race to the finish. And they are told not to share anything. They're told if they want to put something in open source, they have to defend to their investors why that should be done, why it won't hurt them, and especially when it comes to telemetry about how the internet is being used. They have a lot of work to do to defend any ideal they have about working cooperatively with their competitors. And that is the ethos of the waters I swim in. That's the way the internet security industry tends to work. So we know, in spite of all of that, that an attack on one of us will become an attack on the rest. And we know that if everybody else can be attacked, then it doesn't matter how safe you were, because they will become a launch point for some kind of an attack, whether it's botnet or DDoS or whatever it is that you cannot withstand. Therefore, other people's safety is ultimately, in the medium to long term, important to your safety. Very hard, again, to explain that to a venture capitalist. And so when you disclose a vulnerability in your product or some other product, or an attack is successful or not against your network or against your products, there's a loss of prestige. You are seen briefly in the headlines as the company to whom that happened. On the other hand, if you do that, it will ultimately make the economy that you're in stronger, which will mean that your business conditions have improved. And so sometimes you have to take a short-term hit to achieve a medium to long-term benefit. This should be obvious, but again, I'm telling you, outside this room, this is not obvious. I get a lot of questions on this slide from the security industry rather than from the internet exchange industry. So when you're sharing, it's important to not only share incident reports, after-action reports, or even live-action reports, but also to share the baseline telemetry. We've learned this from NetFlow and BGP sharing, which is that if you're going to be able to detect an anomaly, and you're going to be able to maybe do something about that anomaly, you're going to have to know what non-anomalous behavior looks like. You have to have a baseline. And it's not just you, everybody in the same waters that you swim in has to have that baseline. Getting back to those rights that must be observed, we have never had personally identifiable information in our network. This is not just because I started it in a nonprofit before we moved it into Farsight, but because I believe in the moral right of people to be able to use the internet without being tracked if that is their desire. So because I want to function at the core below the level of end-user choice, I have to pretend that those choices are as constrictive as possible, and they are. And so a lot of my fellow security companies in the U.S. economy have been running down the hall with their hair on fire because of this GDPR thing that Europe has foisted upon the world, and for us it was a non-event. I think that's important. I think that if what you want to do is create an ecosystem of information sharing that people feel comfortable participating in, you should begin by respecting these moral rights, even before they were also legal rights. So, in 2007, as I said, we launched this Security Information Exchange, and at that time it was not-for-profit. We've since changed that. I can explain why later. And the fundamental idea was to have sensors everywhere. A sensor in this sense is a piece of software, open source software that we would provide, and it would operate very much like a hub and spoke. So if you imagine a bicycle wheel, the sensors are at the rim and they all transmit their information to the hub. This requires that the hub be highly trusted because they have to not only respect all of the information rights, but they also have to choose who can receive the information that has been sent. Because if you start sharing it with spammers or sharing it with others who might have harmful goals, then ultimately your sensor operators will be chilled and you will discover that you have no data. But I thought that ISC was a great place to start this. Ultimately, it turned out to be capital constrained. In other words, the problem was much bigger than I could do fundraising for. But it was a problem I could address if I had customers who were paying for stuff. So even though it's now a commercial company, we are still giving the data away to academics and sort of nonprofit internet superheroes who just like to fight bad guys in their spare time. Really anybody who has a public benefit purpose and isn't making money from it is still getting the data for free. That's somewhat unusual, and if I had venture capitalists, they wouldn't let me do it. But in any case, everything has grown. Everything is about 8 times the size it was when we moved it into a separate company. And we still have no PII, and it is, I think, a success. I think we have achieved quite a bit. There are problems, however, that I'll get to. First, you're going to see this picture again. I have been graciously allowed to speak twice today, and I just want to explain where the non-PII is happening, because this laptop is a stub resolver. It's that bottom cloud. It's talking to a recursive server, probably on this LAN somewhere, but maybe belonging to the ISP. And all of the transactions between this laptop and that recursive server have PII because they have the end user IP address that can be found, bound up to the MAC address through DHCP logs and ARP logs, and you can eventually find out who made a query. And as a result, we don't scan down there. We have competitors who do, but we don't. We look at only the transactions from the recursive server out to the internet when it is asked a question it doesn't know the answer to, a so-called cache miss. Now there's additional anonymization and vectorization and compression that squeezes out even more PII after that, but that's the fundamental design premise, is that nobody should be surveilled unless they have given explicit permission, and I don't have a model for gathering that permission, therefore I assume I don't have it. That's a good design primitive for all of us if we want to build something that will scale to the size of the world. So GDPR has raised this business of PII and permission and who owns your digital exhaust to the global stage, and I think in a good way. Microsoft, as an example, has already announced that they cannot afford to figure out who among their users and customers is a European data subject and who is not. So they have to assume that everyone is, and so they are going to give GDPR-level privacy rights to everybody, including those of us in the US who are used to being surveilled by our corporate masters, and it's all because of you guys. It's all because of this GDPR thing. So thank you for that. Nevertheless, GDPR has also had a bit of a chilling effect on the growth of our network in Europe. Now, we are always able to explain this picture, and we have various white papers, and we're coming up with improved white papers, so that if some university administrator is concerned about student privacy regulation, or maybe a telco is worried about government privacy regulation, and they say, well, we can't run a sensor because of law or because of rule, and I can show them How that rule does not apply to what we're doing, and you know, sometimes takes hours, sometimes takes months, but we eventually win because, in fact, we're not doing anything wrong, and the truth in this case can win. But a lot of people are not sitting down with me to have that conversation. They're just walking away. They're refusing to even consider the idea because they are afraid of GDPR. So rather than treat that as a problem, I treated it as an opportunity. And so we have now created a company in Germany that is nonprofit. It's a limited liability company. Which means it has to be owned by people rather than by other companies. We will change it to a full company with a nonprofit board in time, but right now we're just trying to get it off the ground. It operates completely transparently, so you will always know our finances, you will know our policies, you will know our corporate governance and so on. The founders are three of us, myself from the US, Christoph Fischer from Germany, and Peter Cruz from Denmark. And the reason is that those are the two guys who would return my calls and actually help me with this. And so that's in progress right now. And the great thing is it is under European law. It's governed. It's a European company. It is a German company, which is even stronger than GDPR in terms of what you have to observe in national privacy law. And the idea is that somebody who hears, yeah, there's a security information exchange, and I would only be sending my data to another European entity who is also under the same legal regime as me, is more likely to at least consider the possibility instead of walking away and say, oh, I can't send the data to California, I'm not even going to think about it. So this is to get people to think about it. But there have to be some other rules in order to uphold all of this. So we're going to collect the data, and we want it raw, and we want it in real time, and we will filter it. There will be some filtering in the sensor to remove PII. There will be more filtering at the hub to remove even more PII. And everyone who contributes will get a copy of the channel they contributed to. So if you're in the passive DNS area, if you have built the traditional ELK stack for this, or if you have your own tools, then this is a way to magnify the size of your collection. Because instead of just collecting data from the people you went to college with and shared a dorm room with who were willing to run a sensor for you, you can take that data and send it into this central hub and then get a copy of everything else that is also being collected inside Europe. I want Europe to be extremely well studied by Europe. So some people can't do that. The idea of receiving a real-time broadcast of that form scares them because they don't know what the heck they would do with it. It's fun to watch, but there's a lot of it, so you have to sample it. So we're also going to run a small passive DNS database that has only European observations and only a few months of history. So some sensor operators will say that they want access to that database instead of access to the real-time feed, and that's fine. The reason we're not running a bigger passive DNS database is because of the same reason that internet exchanges don't offer transit, which is that you don't want to compete with your participants or you won't have any. So what we're trying to do is leverage the fear of GDPR into more sharing, and everybody in Europe who knows what to do with this kind of information should be able to get as much of it as possible under the law. And this is, other than for Farsight, this is going to be a European entity. So we're the only European or non-European company who is going to be involved here. So we're going to see the fully anonymized data once our lawyers tell us that it is legal to export that fully anonymized form, filtered, deduped, compressed, etc., outside of the EU. So we will see that in our global database, and no other non-European company will. That is my payment for this. I'm investing a lot of time and a lot of money helping Europe observe itself in exchange for this exclusive. So in that sense, I am a commercial bandit, and I'm sure that my competitors will have something to say about it. These dates were wrong by at least 6 months. We're still hoping to start testing. It turns out that incorporating a company in Germany is harder than I realized. And so although we have equipment and address space and the rest, we don't have a company yet because it just I don't know why, everything takes longer there. But that's what I'm really here to announce, is that This is a no-fee effort. We're not going to ask anybody to pay any money. Just send us your data. And if you do, and you send us, I mean, don't run a recursive or a sensor on your personal laptop's recursive servers and send us 3 cache misses a minute. That's not going to help. You will not get access to much by doing that. But if you have a legitimate network, university, a company, government agency, whatever it is, and you're sending us everything you have, then we will answer by sending you everything we have. So I guess the last point I want to make is that 10 years ago, when I was still with ISC, I had made the rounds in Europe trying to get people to share data. And I ran into some colleagues over at Deutsche Telekom who said, yeah, we used to be the German PTT. We've got a lot of regulation. We cannot send data to California. But thank you for these tools. And so they have been running their own passive DNS collection system. And this was built for them. And they have agreed to participate in SIE Europe because they want to see the rest of the data, and they don't care who in Europe sees the data that they're collecting. So I do have an anchor tenant for this in addition to CSIS and BFK, who have large collection networks. So in other words, this is me trying to help. So I don't know how much time we have left, but you'll see me again later in the day.
Any of the very large, thank you. Do you know if any of the very large public resolvers are willing to take part, or have this signal that they may take part in the future? Without naming any of them in particular, there are 3 or 4 famous ones at the moment.
I don't know of an Anycast provider who is incorporated in Europe, and so that hasn't come up. But if it did, we would certainly talk to them. And you know, the reason that these companies pay so much electric power bill and so much staff cost in order to build these Anycast networks is because they want this kind of data. So this would be a fairly natural way for any of them to say, I'd rather have more data.
Yes.
But they might say, we can't survive in an economy where other people can see our data. And in that case, I think they're cowards. I think it's better to say that we should compete on what we can do with the data rather than on what we can see.
Yes. There is another question from the front.
Hi, Paul. So passive DNS is one of the launch services. Will you mirror the channel structure of SIE US into SIE Europe, or are there other channels that you are going to launch at the same time with the passive DNS?
So Kauto points out that in the global security information exchange, we have a lot of channels. There's 40 or 50 of them, and there's a lot of other kinds of data that we gather and exchange in real time. For example, spam or malware signatures or syslogs or firewall logs. There's an awful lot of stuff. And so the architecture that we're using is the same, and so it would support a multi-channel infrastructure in Europe. However, we have 3 very busy, disorganized people trying to start a company and launch one channel, and I am not willing to put before them the question of whether we should also do anything else until we have got that much done. But yes, the goal would eventually be that, let's say, if this turned out to be a good hub and spoke model for BGP collections or NetFlow collections or anything else that otherwise has to be shared on a whole bunch of point-to-point TCP sessions between participants using 0MQ, then yes, we will get into that also. I'm happy to see it expand. That may be something that we wait until we have a full GmbH with an elected board to do, because it may be that the 3 founders can do exactly this much and no more, but the sky's the limit. It's up to Europe what happens to this.
Good.
Thank you.
Well, thank you so much. Thank you. Okay, Alessandro, it's time for your presentation. It's another security-focused presentation, which I think will be of lots of interest to people who are interested in increasing the amount of understanding they have about what's happening to their announcements around the world. Thank you.
Hello, everybody. Thank you very much for the invitation here. It's a pleasure for me to be here in Tampere and tell you something about the little project we are running in Pisa. I'm a researcher at the Institute of Informatics and Telematics of the Italian National Research Council. And since 2009, me and my colleagues are running, are trying to understand something more about the Internet Autonomous System level ecosystem, trying to shed some light on some of its hidden characteristics, like, for example, inferring some inter-autonomous system economic relationships, or in trying to infer geographic information from BGP data. Like many other researchers around the world, we are currently relying our studies on BGP data collected from route collectors. Route collectors are nothing more than Unix devices, typically, which run a BGP daemon, which establish a BGP session with volunteer autonomous systems. These BGP daemons, namely Quag or Bird, establish a BGP session and receive all the data, all the routes from their peer autonomous system connected, and dump every information in a public repository, which can be used for our analysis, for example. The route collector will never announce anything back to the connected peer to not interfere with its routing, and will never analyze user traffic, of course, because it's just collecting routes. Sorry, just a second. FN, okay. That's bad, sorry. These are the most famous route collectors running right now around the world. There is the RouteViews project and the RIP-NCC Routing Information Services, which are the most historic ones and are collecting data since the late 90s in MRT format. Plus, we have Packet Clearinghouse, which is starting to collect data in MRT format since 2011 from their peers. The problem about this data is that data is largely incomplete. Last time I checked, it was June 11th, I tried to make a fast analysis about that. And I found that only 1,000 autonomous systems were sharing the routing information in V4, and about 600, 700 in V6. Even worse than that, only 232 of them, of the V4s ones, were sharing full routing information, and only 187 were sharing their full routing information in V6, which is a very, very low number if compared to the 60,000 autonomous systems currently composing the internet. Even worse than that, route collectors are mostly connected to the top of the internet hierarchy. So taking into consideration the scenario on the left, if the route collector is connected to the top of the internet hierarchy, like with E, then due to the presence of BGP export policies and the economic relationship between autonomous systems, the autonomous system will never announce anything, any route crossing the peering connection between A and B and C and D, since a customer will never announce to its provider any route alert from a peer or from another provider, to not become a transit, of course. On the other hand, if the route collector was connected to the lower part of the hierarchy, like in the right case, it would be able to do, at least to have a chance to reveal them, depending on the BGP decision process of the autonomous system crossed. Like in this case, he was able to see C and D and A and B, for example. This means also that most of the connectivity established at internet exchange points, like TREX, for example, are currently not seen in BGP data. And every study analyzing BGP data and trying to conclude something about this exchange point role in the internet is currently heavily underestimating them. We went a bit further with our studies. Don't worry about the mathematical equation. I don't have time to explain you about the problem, and it's going to be boring. The most important part is that we found a way to understand how much incomplete the topological information of the internet are, and using the chain of customer-provider relationships found in autonomous system path in BGP. You can find here some information about the paper we published about that. The most important part about this problem are the results. As you can see, we found that we were able to discover only 6% of the autonomous system transiting V4 traffic for other autonomous systems in the internet. reveal the full connectivity of those autonomous systems, which is a very, very low number. 35% in V6 case. And this is common all over the world, almost in every country. Here I highlighted Finland, for example. At this point in time, we asked ourselves if what was the problem, why BGP route collecting was not heavily used by autonomous system administrators. And we believe that one of the possible causes was that was the volunteer basis the route collectors are currently applying. And our answer was the Isolario project. Isolario project is an enhanced route collector, still free for everybody who decides to participate, which offers something back to whoever decides to participate to the project. So, full routing table in change of services, mostly real time, that can be used for troubleshoot the reachability of their own the network of the autonomous system administrators. These services are available only for feeders and whoever decides to participate. This is the rough architecture of the Isolario system, the real-time Isolario system. On the far right, you have the feeders, which are connected in multi-hop BGP with our route collector, which are doing exactly the same thing as route user RIS. They collect incoming BGP packets, they dump them in member format, you can find them on our website. Everything is then announced to each application we run on Isolario, which make a first brief analysis of the packet. Everything is sent and analyzed, crunched, and merged in the core intelligence. Then to the web server, which offer all the results of the analysis we make on web sockets to the feeder administrators. Feeder administrators then all they have to do is establishing a BGP session with us and use one of the most common web browsers to enjoy our services. As I told you, the services we made are totally free for each of the participants, and these are a brief list of what we did so far. So we have real-time monitoring services, some diagnostic services, hopefully soon some historic monitoring services as well. And now I'm going to show you a brief video of a couple of them. In the meanwhile, if you want, you can try Isolario, just log in with the guest credential. So the first application I'm going to talk to you about is subnet reachability, which is, in my opinion, one of the most important in Isolario since it exploits all the feeders we have connected at the moment. With subnet reachability, for example, a network administrator can understand whether how its network is reached from each of the participants in Isolario. As soon as the administrator click on subnet reachability and put in the network he prefer, all the information are dumped from our route collectors, and every packet is flowing in the system. Each row, each color is a different feeder, and all the information can be expanded, and you can see all the attributes of the BGP packets, the reachability of the route. Plus, we have also some information about PNDB, about to understand whether the route is potentially crossing an exchange point or not. Then, thanks to the collaboration of Massimo of IIT-CNR, we also introduced in subnet reachability BGPlay in real time, which is a new version of BGPlay, which would help you to better understand what's going on, since, as you have seen, the number of feeders is quite high right now, and with the graph is better, you can easily understand what's going on. I won't say anything more about BGPlay, but I strongly suggest you to check the website. Then we have the alerting system, which is a regular alerting system, where you can set up your own trigger. I'm going to show you one of the triggers based on some characteristics of the BGP attributes of the incoming packets. As you can see, I can limit the number of mails to 1 hour, for example, my choice, and I want to see all the packets starting with a particular autonomous system path. Let's say 2598, 137, 174, which is my autonomous system, my provider, and the provider of my provider. So it's very common that they will show up. As soon as I set everything up and click on save, I'm going to be redirected to this page, which is just a summary of the alerts I set up, and if I go to the notification summary, I'm going to be able to see all the packets flowing in the system and matching the criteria I just set up. Of course, I'm going to receive also an email, and in real time, thanks to the WebSockets, I'm going to see all the packets flowing into the system. Like, for example, should happen right now here. Okay, and in the end, you can use a network administrator can use Isolario to check if everything is going okay on this network, checking the real-time services. You can check whether it's something weird is happening right now, checking being alerted by the alerting system, and can check how was this reachability of its own network or its autonomous system, just checking some daily reports we make in PDF and make available to the public. These are some numbers of Isolario right now. We have 127 autonomous systems participating with 368 sessions configured. Most autonomous systems are connected in the IP region, and most of them are in Italy for obvious reasons. We have currently 122 full routes in V4 and 133 in V6 from about 80 different autonomous systems. So not every autonomous system participating is currently contributing with a full route right now. The most important part about this slide is the fact that most of the autonomous systems participating are not connected either to route use or RIS. And that's a good result for us because it means that we are currently improving the situation and help the community to have more complete data. Plus I have some news, which is the introduction of headpath in route collecting in Isolario. For those of you who do not know about headpath, headpath is a BGP extension which allow a peer to announce to another peer not only the best routes, but all the routes it's receiving from its own peers. So it's perfect for route collecting, and it will allow us to have multiple full routes from one single feeder. Right now we are in a test phase with that, but we are almost over with the test phase. I didn't announce that to my feeders, so the number of autonomous systems participating is still low. We have 13 autonomous systems right now sharing the routing information. The nice part about that is that with just 13 autonomous systems, I almost double the number of full routes I had in Isolario. So we have 53 additional feeder in V4 and 54 in V6 with just 13 autonomous systems connected, which is quite good. Right now, we currently provide to the community some data and some tools. We provide the MRT data, of course, like every other route collector, since that's our main purpose. So you're gonna find our feeder snapshot RIB snapshot every 2 hours, and update collection every 5 minutes. We use the same format as other route collectors, so if you have any tool analyzing MRT data, you can easily use our data as well. Just introduce them in your system. Our data is currently used by Hurricane Electric in bgp.net. So if you would like to see better results in that tool, you may consider to participate to Isolario or to any other route collecting project, of course. We make some periodic analysis on our website, and most important, we try to make as much open source software as possible. We have right now the interactive collecting engine, which is the BGP daemon we are using, which is totally devised for route collecting, which is right now open source. And we also made available our MRT data reader library and software, so you can easily read the data we are collecting. It's not over, of course. We are currently trying to every day to improve the system we created. Hopefully soon we're going to have some Bogon real-time recognition in our system, so that we are going to cross the routing information coming from our feeder with the Bogon BGP session offered by Team Kimro, for example. We're going to do some effort to make an open source looking glass to use it, which would exploit WebSockets, for example. And I hope soon we're going to be able to have a route collector on BMP as well. That's it. I thank you really much for your attention. I hope some of you will decide to participate to Isolario and would help us to have a better view of the internet in Finland. If you want to participate, just contact me offline or at info@isolario.it, and that's it. Is there any question?
Any questions for Alessandro? Yes, we do have a question from Paul and Natalie.
The Isolario was funded at the beginning from the cctld.it in 2013. The funds are over this year, and I had the word from cctld.it that they will continue to help us in keeping Isolario on. They were telling me that they use it as a service in register.it, so it should stay open and free for everybody.
Hi, this is Aleksi. I just wanted to interject that if you want to ask questions, please wait for the microphone so people watching the live streams will also hear the question.
Yes, I'm Natalie from RIPE NCC. Thank you for mentioning BG Play, of course. I had a question because I was taking notes. It went a little bit too fast. The percentage of people that you now see on the route collectors, thanks to this project, what was that again?
The percentage of people?
Yeah, so...
This slide?
Exactly, yeah.
It's like 70% of autonomous systems which are not connected to RIS on the route views.
70%?
Yeah, well, that doesn't mean that we don't have the same views of them. I mean, it depends by the coverage. I didn't do the proper analysis to understand how much we are currently improving the situation, but that's just at the beginning of it.
Okay, interesting, thanks.
Hello.
Hi.
My name is Jan George. Well, thank you for running this Isolario. We decided to participate as Go6 Lab. Back in the days, we are providing the data, and this has been very, very useful. And it was also nice how we configured the BGP sessions, right?
Yeah.
Thank you very much.
We were on the top of the Sahara doing that in a plane. It was amazing. The highest BGP session ever made in Isolario.
Any more questions? No? Well, thank you very much.
Thank you very much.
Okay, so the next presenter is our host, so I will be introducing Andy Davison from Asteroid to give a presentation.
Perfect. Thank you so much. Thank you, everybody, for the opportunity to talk to you about something that I've been very, very interested in for a little while. I think it's the second or third time I've given this presentation, so hopefully people in the room aren't bored of it. I've certainly never given it before in Finland. A little bit about myself and why I find this interesting. My background is as a Unix and network engineer. I became very interested in automated service orchestration and orchestrated provisioning, for example, a little while ago. And one of the things that I learned quite early on is that you actually have to model very carefully what it is that you intend to configure and what it is that you're building. And I'm going to talk today about my experiences building an automated internet exchange point service. But I hope that some of these lessons might be interesting to people who run networks to provide other kinds of services if you're approaching an automation project for the first time or looking to improve or build upon an automation project. So most network engineers begin an automation journey by working on an existing network and producing maybe some simple reporting software, That's a really good place to start because it's very low risk. When you're reading information from your network and not making changes, you get something useful out of that, and you're not changing something, so it's the risk of breaking something is very, very low, and you're actually getting some experience with the libraries that you will use to do more complicated things later on. Eventually, once you become quite comfortable with building reports and getting information out, you start to think, hey, well, this tool or this process is a little bit boring. It's looking like a candidate to replace with a bit of a script here. So you discover that actually you can change your reporting scripts in a small way and produce some kind of simple automation that allows you to do things like set up a new peering session, for example. Eventually, your scripts and tools become a bundle of tools, which are a bit like an application. And then instead of configuring a network device, you start to configure the network state. You start to configure the network rather than the device. At this point, state becomes a problem. You know, if I'm configuring an end-to-end service and it works in one place and the other place it doesn't yet, you've got to start to manage that complexity. But eventually, you deal with that complexity and it becomes a lot more like a fully fledged application rather than a set of scripts. And then the ultimate place to end up with your project is to embed the work that you're doing, the business processes that you're automating on the network, start to impact and improve the work that other people in your business can do to support the business, and you become a rather more automated business entirely. At that point, you're not configuring the network, you're configuring the entire product set, including invoice chain and that sort of thing. And that's really what this presentation is a little bit about. It's about offering the technical perspectives and my thoughts on an architecture for a greenfield deployment of a fully automated business that operates internet exchange points. Why do we decide to start with software? Why do we really start to approach this as a software company rather than a network? Well, actually, we had to be able to replicate our exchanges in lots of places because we want to run exchange points as a service for people. So the ability to replicate very quickly was very important. By building software that can do our jobs for us, it encourages efficiency and leanness in the organization. And it also allows us to deploy services very, very rapidly so that we can, first of all, make customers happy with rapid service provisioning, but also keep them happy because we can monitor their services in an automated manner as well. In order to build automated tools and build this automated business, we had to build, as I mentioned earlier, a data model. And I'm going to talk about what a data model is and how to build it, the problems that I came across and solved modeling everything that we do as a business. And hopefully there'll be a little bit of time to talk about the software architecture that fell out the back of that and some of the things we do with regards to software testing in an automated business. Now, what do I mean by data model? Well, it's simply a description of all the things that your business needs to know in order to operate. So in order to operate, you need to know who your customers and suppliers are, what you plan to do with these customers in terms of selling them some products, how you're going to configure that and where. And the simple way to start to build a data model is to start with a steady state of the business. Map out what it is you know about the people who work for organizations, who are buying products from you or selling products to you, and how you configure those services. And then model the interactions between those things. So once you've modeled the people who raise purchase orders on behalf of organizations for a product, the interactions between the things in the steady state of your business can also be described in a data model as well. So, for example, a quote describes who raised from which organization a request that you build which product. And then if that quote is accepted, how that product is rolled out and where. These are the interactions between things in your models. Why would you care about something like modeling a quote from a purely engineering point of view? Well, I make the case that it's very useful to understand every stage of the business process in a technical organization, because then you can do things like monitor based on what's written in the quote. If your technical systems understand the business process, for example, what somebody in the sales team has quoted, you can then build your Nagios or Isinga or whatever configurations from what's on the quote. So you end up monitoring what the customer's intending to buy, not what is rolled out. And that's quite useful. When you're modelling the data, it doesn't all have to live in a system that's controlled and operated by the engineering team. Data actually lives all over the place in an organisation, and it's important to know where. For example, you might find that your finance system, finance person or team has got some data that lives inside a finance application, like Xero or Visma. Your sales team are probably using, hopefully using something like a CRM to track opportunities, and you'll have your own tools in engineering that help you store information and documentation about how things are configured. It's actually fine for all that data to live in different places. That's not a problem. That's perfectly normal within a business. But it's very important that if that data lives in separate places, you're calling that data the same thing. You're able to point to something and say, actually, this Search Engine Netherlands in the finance database is the same as Search Engine Inc. in the sales system, and Search Engine in the support system, and well, in engineering we just deal with Fred. And it's very important to understand that these are the same record, the same entity. And it's not fine at all for data in more than one place to be entirely authoritative about a single kind of record. So the key thing that you need to do is decide which database, which application, which part of your system is going to be the authoritative record for each type of data that you know, and find a way for all of your other systems to point to that single authoritative source as a single source. So if when you've built your model, when you've described everything it is that you need to know in order to run your business, it's the rules become to store any item of data once. When you're storing the organization about who your customers are, you record that once in one database, in one application, and you use that from across the rest of your business. Give each record, for example, an organization or a person or a contact or a device, give it all a unique identifier that has nothing to do with the record, that stays constant in your business. Anything that's a piece of business information that you might use as part of the configuration is not a good idea to use as the unique identifier. So an AS number looks like quite a good number to use as the record for like an organization or a customer or something, but actually it's a very bad idea because a company might merge or start a second network or something else. So it's important to use a unique identifier that's not part of the business logic as the identifier, and then decide where it will be authoritative in your business. As you probably realize, this requires quite a lot of buy-in from other teams. So it's important to understand and sell the advantages of having automated workflows to the rest of your team so that people can agree where the data will live authoritatively. It's also important to actually separate data inside your model. So it might be very tempting, for example, if you're running an exchange like us, to put information about the ports and services together in the same table. But very, very quickly you realize it's a bad idea to store infrastructure elements and information about what's configured like a service on those elements in the same table. It helps you improve the portability of your application and what you can do with your services later on when you separate actual product information or service information from the infrastructure elements altogether. For example, if you're going to start stacking multiple services on a port, it's an obvious reason to separate the data. Once you've decided to build a model for your business and decided that you're going to keep some information within a database in engineering, there are a number of fashions that you might like to consider when you're deciding how to architect your database. I've done a number of greenfield and retrofitted installations of automated workflows in businesses, and I've worked with people who've convinced me to try the document store style of database and the traditional relational database model. The development team in a previous business where I worked on an automated network and recommended, and we went with the document store style of database, because document stores tend to be incredibly extensible and less strict. And they use the argument that, well, you don't need to care about databases being small and efficient because storage is free now, isn't it? Or we can be lazy. With that automated network, we learned actually that strictness is a benefit. causing you to have to store the information in a single place in a strict relational model was very much a feature, because it meant that the data would either be always right or always wrong in one place, and if it was wrong, you could fix it in one place and it would then be correct everywhere. The common sorts of data stores where I have found it's interesting to keep information inside your model is a choice between SQL databases, which store long-term truths about users, ports, services, and the state, for example, of a part rolled out service. And also time series databases. I've started to use InfluxDB to record information about port utilization, light levels received, error counts, so that I can use that as part of the model that I'm building when I describe a port or a service that a customer has. And it's also useful and good to look at third-party information, so that you might be able to incorporate someone else's data about your customers. Say, so for example, when we are looking at an ASN and using that to configure information about services, I actually pull in information from, for example, the EuroIX or IXF database and the PeeringDB database to look up things like how many what should I set as the max prefix on the route service, for example. It's a useful thing to do, to go and get third-party data and put that into your model as well. So I've decided to build a model. I've decided to describe where data sits in my organization. I've started to record data in a database about devices, services, configurations, customers. They all live somewhere in a set of databases that I can map. I understand where to get information about my business. How does the software look like in order to run to deliver an automated service? I think the middle bit of this slide is the interesting one here. The way that I've approached this a few ways. The way that seems to work best, and the way that we've done this now, is to have a single API layer in the middle that allows us to develop services and tools and monitor the platform in a single place, which actually feeds to a larger number of services on the back end. So I can have data in a CRM, I can have data in a time series database like Influx, data in MySQL database, and also information that's actually stored on devices in the form of what the real configuration is, all reachable by client utilities like scripts, portals, and even what we expose to customers through a single channel, through a single layer. So there's one URL to go and get information about a port, for example, that comes from multiple backends. The current utilization comes from one database. So parts of the configuration record come from another database. And also I can go and get information from the switch in real time by calling one single URL on the API. Doing that makes it very easy to expose all of your tools and data to customers. My argument is that actually this is a very good thing. The traditional telco mindset would have been not to expose information about what's happening in real time on a customer's DMARC perhaps, so that you can manage the support workflow, for example. But my argument actually is that the more pluggable, the more data we expose, the quicker issues can be resolved, and the happier your customers are. And your customers have a reason to stay with you and work with you because they're getting more benefit from that as well. Now, the API, as you can imagine, information that's kept in third-party databases like the IXF database or PeeringDB is stored in a different way to how data is stored on an internal MySQL database, or what's exposed by your CRM's API, and what's coming off an Arista switch or something like that. So data in its raw format can be in lots of different formats. You know, it could be XML if you're unlucky. If you're passing all of that information, if you're sorting it on a common API, as well as some performance wins you can make there, such as a bit of a caching layer or something like that, you can actually transpose however the data is stored in the back end to a single common format. So if you have, let's say your CRM's API is XML based, you have some information, some legacy information in a CSV file or something like that. However that looks, your client scripts and your portals and your own applications, your tools, what you expose to customers, just needs to be JSON, a single a format that all of your tools can use and interpret without actually having to understand the native format used in the back-end storage model. And this is an example of what it looks like. So we have our API in the middle, which goes and talks to the various types of databases and the various places where real-time information lives, like on the switch. So if I make, what's the top left one? The top left screenshot here is an example of a request that's made to our API that a customer can make that goes and pulls information back from a bird route server, a bird collector, and our internal SQL database on a single query. And on the bottom right, that is a dump of information we would share with customers about ports. You can see information again from our internal SQL database, but also stuff that's coming directly from this, in this case, an Arista switch, and the data that's coming out of the time series database to do with port utilization, for example. So you can see that I'm going and getting information from many different sources that store the information in many different ways, and I'm making groups of data that's relevant to a single thing available in a single URL in a single format, in this case JSON. That's the advantage of that kind of architecture. Now, once you've modeled everything, once you've got all of your information from all across the business in a family of databases that you can address through a single API layer and interpret in a single JSON document, you can then harness the power of templated configuration. So as the data model extends across the business, you can devolve control of your monitoring systems, your switch configuration, router configuration, servers, to the automated system with the power of templates. Why would you invest so much time and software architecture in doing such a thing? Well, it actually means that it reduces the amount of work that I have to do so that I can come to Finland and enjoy my time without the business waiting for anything from me. As an example, our salespeople can deliver exchange ports on any of the exchanges that we operate directly from the quotation system, and so can customers. So this allows us to monitor, provision, and then on an ongoing basis monitor those services based on somebody clicking, yes, this is what we want, in a quotation application. And templates are part of what I call fire triangle. You can't actually have a full automation without all of these things working together. The structured data in your model, some software that automates the processes and describes those processes, and then the templates that push them out. There's a number of templating engines and systems. The one that I particularly like is Ginger. I like it because it works well with Python and Flask, which is an environment that I'm very comfortable working in. It allows you to generate any type of configuration, any type of like flat file configuration based on a template with variables that can be replaced. And you can use programmatic facilities in there like for loops and if conditionals. And it can take variables directly out of your API because, of course, it's exposing all of that raw information via JSON. For the automation, we haven't produced scripts and standalone utilities for every kind of change that we need to make. We just describe all of them in an Ansible playbook. What does this do? Okay, this is a fragment of the book of a playbook that changes root server configuration and IX. So it goes and gets the JSONs. So okay, it gets a good JSON document that's in the EuroIX IXF format for a particular exchange point, and then it goes and rolls out the collector configuration, so that everybody who's on that exchange gets a BGP session collected on the collector, and it restarts the BGP server. Here we go. This one's more interesting, and this is one that runs on the route server instead, that goes and gets prefix information out of the IRR database based on what someone's saying they're going to announce on their BGP sessions, and then creates filters so that our route servers don't accept prefixes which are not registered in the IRR database, which is something that everybody should do. what are the advantages to that multi-layer system? It means that the API layer is very, very lightweight. Although there's lots of complexity in the system, because at some points I've got to go and touch switch configs, at some points I've got to go and touch Linux server configs, at some points I'm changing information in an accounting system. Actually, you know, there's lots of complexity towards the bottom of the stack, but at the top of the stack, where my scripts and where our web portal and where customers are interacting with us, it's actually a very, very simple, lightweight API. It's just go and get some information from somewhere that's well defined and return it, and you can write it in pretty much any language that's familiar to you, which is why we chose Python. Yes. Do ensure that your API choices allow you to store, retrieve, and process business logic as well as technical products. So, for example, when we were actually modeling everything related to the exchange products that we sell, we made sure that we also modeled the parts of the service that don't require configuration at all as well. So, for example, when a customer suggests they would like to see us build an exchange point in a particular city, they're encouraging us to build a campaign to run an exchange point in a city. We model that in the database as well, because actually having that structured data allows us to sort and interpret that in our tools really, really simply without additional manual stages. Some words on what's happening in the bottom left of the stack, the worker architecture. This is an interesting bit where there is quite a bit more complexity than there is in the towards the top of the stack. It's important when you're deciding, so what these devices at the bottom represent Arista switches, and the W means white box switches, to indicate that multi-vendor is something that it's worth considering when you consider worker architecture. You need to consider inter-process communication. How is it that you're going to get a request to do a piece of work on a switch out of the API and into a queue or something that's going to deliver configuration to a switch? How are you going to manage state? Did you get a message back? Did it say it worked? Did it say it failed? Does that mean that the job is finished? How are you going to do it in a way that's device independent? You know, if I might be buying one set of switches today and I want to use Arista in the future, for example, how do I make sure that I'm not locking into a single vendor? How do I handle the swap outs of a device? If a device fails, how do we go and get a complete set of what should be state and put it on the switch? When you look at inter-process communication, there's a number of ways that bubble to the top. A message queue-based system. We heard about one this morning already in Paul's talk, where he mentioned the user an MQ system. We looked at using an MQ system to manage the flow of tasks, because there's quite good support in major scripting languages. It's fault tolerant. There's guaranteed delivery in things like RabbitMQ, and you can enforce order mattering. Sometimes you need to wait for a job to finish before you can start another one. And it's easy to embed order matters in your processing of messages through a message queue. But we went with the by building another web services layer. So because we've got a relatively small number of tasks that need to be that indicate changes, and a relatively small number of jobs that need to be rolled out to exchange points, and it meant that having a web services layer that sits in front of the individual devices mean we could have an identical technology stack to the central API, and it was decentralized. I can have it's easier for me to monitor where there might be a failure. If we lose a single exchange point somewhere, it means that we haven't got any dependency in a central place on all the other exchange points. We also, in order to ensure device dependency, we chose to write a different worker system per backend technology. So there's a different worker system for our Arista switches as there is for our Cumulus support, for example. This means that there's a little bit of a copy-paste code between the two systems, which is an anti-pattern. That's normally something that you try and avoid from a software architecture point of view. But it did mean that we never had to make compromises with how we treated different vendors. We didn't have to say, well, we could do it a better way on this platform if we didn't actually have this logic in here to support this other platform. It means that we can get the best, we can work the most effectively for all of our vendors, even though there's a little bit of code duplication. We also found that something called Napalm, which is a like Ansible extension, or it's a tool that works with Ansible for network devices, allowed us to continue to use Ansible for our switches, just the same as we use Ansible for our servers. Oh, and we also, by using Napalm and Ansible, get device swap out behaviors for free. So when I use Napalm to roll out fragments of configuration, if we need to swap out a device because a switch has failed, we can put a new switch in there and just ask Napalm, can you give us all of the config for this box, not just the fragments? No need for a specific software to be built for a time where, as you know, when hardware goes wrong, something following a strict process in an emergency is sometimes quite difficult. We just have to ask Napalm to roll out the config. Something that I strongly believe in is software testing as well. So we use fully automated software testing at the API layer to mean that I have the confidence to make changes to software that I wrote a year ago. You'll have been involved with systems before where you inherit a script from somebody else, or you inherit a tool from somebody else, or you inherit a tool that you wrote a year ago when you were drunk, or something like that, and you need to make a change to that. And you can make a change to that to support the new feature or the new behavior that it has to do, but how do you know you haven't broken something else? Well, what happens in a legacy environment is that something else stops working, and then a light comes on in Nagios and you fix it, or a light doesn't come on and you wait for someone to get really angry. Software testing allows me to, when I create a feature in the API for a specific purpose, I can write a test to prove that that specific purpose works. Then when I change the behavior of the API a week, a month, a year down the line, then my existing feature, the thing I needed to do with it originally, is tested, and I can see if everything that I've previously written something for still works. The way that I approach this as a non-specialist software person, I really came at this, as I say, from a network background, is I write the test first. I write a test that says, prove that I can use this API call to configure X. And of course, the test fails because that feature hasn't been written yet. That's a way that I can show the test works. I then write the feature, run the test, and it goes green. I can then try and improve the code that I've written to run faster or be cleaner or something else, and see if the test continues to be green. And on the screen there's an example of a simple unit test that proves that 1 and 1 equals 2. There are a number, you can read quite a lot about testing methodology. There are many, many opinions out there, and you'll see debates about integration versus unit testing. A unit test is where you mock an outcome and test to see if that mocked outcome occurs. An integration test is where you actually run your business process on a more end-to-end basis and see if an outcome still works. As a non-specialist developer, I prefer integration tests because I need something tangible that I can touch and see if it still see if what I'm really thinking up from a product point of view is still working. And here we go. Here's an example of what a test looks like. It's a failure. So lots of things do work. 188 things run. One of them fails, and it's because I've obviously changed. Oh, this would have been a good one to catch. Basically, it's saying that I'm checking that a line item appears in a quote, but given a certain set of circumstances. An index error tuple out of range means that the line item's fallen out the quote. So I've obviously written something that caused me to no longer be able to put line items in quotes anymore, and that's normally quite bad from a sales point of view. I've got I can talk at length about software testing in JSON and things like that, but I think it's time to go for a break. So in summary, a single source of truth, modeling what we know as a business, modeling everything we know as a business, and recording it according to best practice in a number of databases, and then using an API to address that information centrally, allowed us to do really powerful things in terms of building our services in an automatic manner and running our company in a lean, efficient way, including things that we're very proud of, such as provisioning directly from the quote for ourselves and customers. It also means account managers can do troubleshooting. So when a service goes live, the account management can see the same tools that I see through our single portal, and naturally first line support can be done by the person who's orchestrating the service from a commercial point of view, and that our customers are very, very happy with that, we've found. So it's something that's really, really working well for us. Notwithstanding the fact that it is time for the break, are there any questions? I see one in the front row.
Yeah, thanks. How do you validate the configuration on the networking devices? So how do you make sure that there is nothing extra in there?
So that's a great question. How do I make sure that something isn't configured on the device that isn't known about in my model? Yes. So we were lucky. This is a greenfield site, so not a single service has been configured or touched other than by our automation. That's how I've been very lucky. Not every network starts from scratch in an automated manner. And this is what I had people ask me, why did it take you 6 months to build a one switch exchange in Amsterdam? It didn't. It took us a time to build a platform that can roll out exchange points, and then we used it to roll out an exchange. So we had our service and product ready before we rolled out our first product to customers. And it did mean that there shouldn't be anything on the switch that our automation then goes out and breaks. If it is there, it shouldn't be there, and that is an error condition in itself. But so everything in the database, everything in the model should be what's rolled out. But I can say that because I'm lucky enough to have been able to do this from a completely greenfield point of view, and not everybody approaching this project would be able to do it from a greenfield point of view. That's a good question. No. Okay.
I've understood that this Japanese tier 1 called NTT also does something very similar in their core. Have you shared experiences with them?
Yeah, Job there and I have shared many debates, and he's actually a great person to talk to, especially about the things where he disagrees with the things in my talk. He thinks that Ginger is a dreadful templating engine because it's very good at dealing with things that look like a document, but configuration doesn't necessarily look like a document. Actually we have some interesting things. They use a lot of M4 rather than a lot of Ansible, but fundamentally I think that and their problem space is much larger than this one, but I'm very, very impressed with a lot of the things that they've been able to do to improve the experience for their customers, such as strict prefix filtering that allows them to protect their customers from accidental announcements and things like that. That's all driven through an automated manner. There's no way that could scale without that being true. So it's another example of why doing the right thing in an automated manner can actually lead to better outcomes for customers and the internet at large.
Well, Andy will be at the sauna, so if you have any more questions, save them for the sauna.
Thank you so much. And now it's time for a break. So please head to the refreshment area.